In Unit 4, we're going to be talking about polygons and different types. So 4.1 is called Angles of Polygons. And a lesson objective, I can identify and classify polygons, including regular polygons. I can use properties of interior and exterior angles to solve problems. So first of all, many of you have heard of a polygon before. So a polygon is a closed figure, and it's made up of sides. So in other words, line segments. And then the sides intersect at endpoints, so there are no intersecting sides. So polygons, you can see here on the left, they're all closed figures. On the right, there's a couple here that have open spaces, making them not polygons. And then this one right here, you can see that there's intersecting sides, and so that is not a polygon. Also note that this shape is not a polygon because it has a curved edge, so it does not have sides. It is not made up of sides. So note the difference between a polygon and not a polygon. First polygon that we're going to look at here has 3 sides. Most of you know it as a triangle. So the number of triangles then is 1, and the sum of the interior angles we know is 180. We know this from previous lessons. So then the measure of regular interior angles. So a regular polygon has all equal angles and all equal sides. So this would be like an equilateral triangle or an equiangular triangle. So then we know that we get 60 degrees. We can take 180 and divide that by 3. So the sum divided by the number that we have, and so we get 60. Then the measure of regular exterior angles. We get that to be 120 degrees, because as a straight line, this all needs to be 180, so we can take 180 minus 60. And then note that if we added up all of these exterior angles, we would get 60 times 60, or 120 times 120, 120 times 3. So we would get 360 degrees as a total. So note that for later. Here, 4 sides. The number of triangles is going to be 2, because we can split it there. And so then the sum of the interior angles, we're going to take 2 times 180 to get 360 degrees for the sum of the interior angles. So the measure of the regular interior angles, we can take 360 divided by 4 to give us 90 degrees. And then the exterior angles, we can take our 180 and subtract 90, and we get our 90 degrees. So be watching for a pattern as we go through the rest of these. 5 sides. We can split this into 3 triangles. So then the sum of the interior angles, we're going to take our 180 times our 3. And note that our 180 comes from the sum of the interior angles of a triangle has to be 180. So we multiply that by 3, and we get 540 degrees. The measure of a regular interior angle, if we have 5 of them, we can take 540 divided by 5, and we get 108. And then the exterior, knowing that this is 108, we can take 180 minus 108 to give us 72 degrees. Right, up to 6 sides. How many triangles do you think we're going to have here? We can cut off the ends and then split it. So we're going to have 4 triangles. The sum of the interior angles, we're going to take 180 times 4. And so that's going to give us 720. The measure of the regular angles, we can take 720 divided by our 6 angles. That's going to give us 120 degrees. And then the measure of the regular exterior angles, if we note that this is 120, then we know that the outside has to be 180 minus 120 to give us 60 degrees. So let's say we have a polygon, an n-gon. An n-gon is going to have n sides, the number of triangles. Note our pattern, we get n minus 2 triangles. And then the sum of the interior angles, we multiply our number of triangles times 180. So we get 180 times n minus 2. And then we take the sum and divide it by our number of sides. So 180 times n minus 2 divided by our number of sides for the measure of regular interior angles. And the measure of regular exterior angles, before we were taking 180 minus our interior angle. But if you simplify that all out, you're just going to get 360 divided by n for a simpler version. And then note that the sum of the exterior angles is 360 degrees, always. So using those formulas and what we know, the sum of the interior angles of a heptagon is what? So a heptagon has 7 sides, so we're going to take 180 times 7 minus 2. So we get 180 times 5, and we get 900 degrees. Why don't you try B? For an 18-gon, we're going to get 180 times 18 minus 2. So 180 times 16, and that's going to give us 2,880 degrees. Finding the measure of angle A and measure of angle B, but first we have to find x. So this has 4 sides. We see 1, 2, 3, 4 sides. So the sum of those has to be 360, looking back to your chart. So the sum of this is 360. So we can say angle B and angle C are both 90. So we have 90 plus 90 plus our 3x plus our x has to equal 360 degrees. So combining, we're going to get 180 plus 4x equals 360. So there we get 4x equals 180. Dividing by 4, we're going to get x to be 45 degrees. And then measure of angle B is going to be 90 degrees. And then plugging in, we get measure of angle A, multiplying by 3. We will get that to be 135 degrees. Moving on to the next example, number 3. We have 5 sides here, 1, 2, 3, 4, 5. So the sum of those we know has to be 540. So combining all of these together, we can see that we have, combining our x's, we will get 2x, 4x, 7x, 10x. And then combining 142, 14, and 14, and note these are both plus 14. So we'll get 142 plus 28, we'll get plus 170. Equals 540. And then we can combine to get 10x equals 370 divided by 10. We get x to be 37. So note that the sum of all of those, kind of like we were doing in triangles before, but the sum has to be 540 instead of 180. So going in reverse here, if the measure of an interior angle of a regular polygon is 135 degrees, find the number of sides. So using the measure of a regular interior polygon formula, we can set 135 equal to 180 times n minus 2 divided by n. We'll get 135 n equals 180 minus 360. And then combining all of that, moving all the n's to the same side, 180n. So subtracting our 180n over, we'll get negative 45n equals negative 360. Dividing by negative 45, we're going to get n to be 8. So 8, an octagon, has interior angle measures of 135. A regular octagon does. Here, we know that the sum of the exterior angles here adds up to 360 degrees. So note that. Combining all of our x terms and all of our number terms, we're going to get 31x minus 12 and set that equal to 360, since we know that the sum of all of these exterior angles has to add to be 360. Solving for x, we get 31x equals 372. Dividing by 31, we get x equals 12. So note there's going to be some stuff like that on your homework. And then here, lastly, what is the measure of an exterior angle of a regular decagon? So decagon has 10 sides. And remember, the sum is 360. So we can take 360 divided by n, but we know that n is 10. So we get 360 divided by 10 to give us 36 degrees for the measure of an exterior angle of a regular decagon. And just note the difference between a convex and a concave polygon. Convex looks like you can blow it up into a balloon, where concave, you can see it kind of caves in. So note, a concave polygon caves in, and a convex blows up into a balloon. Good luck on the homework.